If someone asked you to spin up a database, your instinct is probably Postgres. But the most widely deployed database engine on the planet isn't Postgres at all. It's SQLite, and it's already running inside almost every device you own. The core difference isn't features, it's architecture. SQLite is serverless and embedded. It's a library compiled directly into your app. PostgreSQL is client-server. It runs as its own background process, and your app talks to it over a network socket. That architectural choice cascades into everything else. SQLite locks the whole database for a single writer at a time. PostgreSQL uses MVCC to let many clients read and write concurrently. SQLite uses dynamic typing. PostgreSQL enforces strict types plus advanced ones like jump, arrays, and UUIDs. And SQLite needs zero configuration, while PostgreSQL needs installation, user permissions, and network setup. Single writer means SQLite locks the entire database file during a write. Fine for one app talking to its own local file. MVCC means PostgreSQL can have dozens of clients writing at once without blocking each other. Essential once multiple people or services share the same data over a network. SQLite needs literally nothing. No daemon to start, no port to open, no user to create. PostgreSQL needs real infrastructure, installation, permissions, a running service. That's not a flaw. It's the price of supporting many clients over a network at once. So why build a database with no server in the first place? The answer starts on a warship. In the year 2000, Richard Hipp was a contractor for the U.S. Navy, working on a guided missile destroyer called the USS Oscar Austin. His job was to help build a system to monitor damage control aboard the ship, tracking things like pipe ruptures and shutoff valves so sailors could isolate damage fast in battle. That system relied on an external database server, Informix, running over a network. Whenever the server process crashed or the network connection failed, the entire damage control application threw an error pop-up, cannot connect to database server. On a warship, that's not an inconvenience, that's a mission risk. It also needed dedicated database administrators just to keep the server configured and running. On a ship experiencing simulated or actual combat damage, having your central database go down could render every client application on board useless. Hipp realized they didn't need a server process running across a network at all. They just needed to query data stored on disk. No lightweight SQL engine existed that could do that without a daemon process. So he wrote one himself. He called it SQLite. SQLite eliminated the server entirely by compiling the whole database engine into a lightweight library that sits directly inside the application, storing everything in a single, cross-platform file on disk. So knowing that history, when should you actually reach for SQLite over Postgres? There are 5 scenarios where it's clearly the better call. First, embedded and client-side apps. Mobile apps on iOS and Android, desktop software built with Electron, IoT devices, embedded systems like smart TVs and automotive dashboards. Anywhere running a background server process is impossible or impractical. Second, low to medium traffic, read-heavy web apps, blog engines, internal tools, documentation hubs. With write-ahead logging enabled, SQLite can comfortably handle millions of page views a day, as long as write volume stays reasonable. Third, edge and local-first deployments. Apps running on FLY.io or Cloudflare workers through tools like Terso or Lightstream, single-tenant SaaS, and local dev environments that need instant setup with no Docker containers or database ports to configure. Fourth, data archiving and portable file formats. Bundling datasets for distribution, file-based export formats for CAD or GIS tools, or long-term archives that need a self-contained, human-readable file supported for decades. And fifth, local data analysis and prototyping, data science work and local pipelines where you want full SQL power without setting up credentials, connections, or ports. Here's the part that actually surprises people. Because SQLite is built directly into operating systems and software libraries, it's estimated to be the most widely deployed database engine in the world, with billions of active instances running right now. It's in the browser you're using right now, Chrome, Firefox, and Safari all use SQLite to store history, cookies, and bookmarks. It's baked into iOS and Android as a core system component, so almost every native app on your phone uses it, including WhatsApp and Spotify for chat history and offline playlists. It's the catalog format behind Adobe Lightroom. Dropbox and OneDrive use it to track your synced files. VS Code uses it to manage workspace state. Discord and Slack use it to cache your channel history locally. It runs in-car navigation systems from Bosch, GM, and Nissan. Smart TVs and IoT hubs use it for zero-maintenance local storage. And SQLite even flies. It's used in the flight software for Airbus A350 aircraft to handle onboard system monitoring. So the question was never which database is better. SQLite and PostgreSQL solve different problems by design. The real question is whether your workload actually needs a server at all, and most of the software you use every day already answered that for you. If this changed how you think about just use Postgres, subscribe for more videos that dig into the engineering decisions behind the tools you use every day.